Alright, my name is Matthew Morgan, and I am working with Rhonda Lee Forbes, Davis Lee, and Corey Fair on a Sinophobia detection project. So Sinophobia is the discrimination against Chinese people, and we are specifically looking at Sinophobia on social media throughout the COVID-19 pandemic. After the pandemic began, Sinophobia has drastically increased since China is the country of origin, and we are basing this project on a previous project which detects Islamophobia content on social media. The project that we are building off of only used Twitter as a dataset, but we decided to use Reddit and Parler to give us both a mainstream and an alternative dataset to make our machine learning models more accurate over a variety of data. We are taking a multi-class classification approach, and we are going with 3 different classes. The first class is clearly xenophobic, which includes terms like these, which are clearly discriminatory against Chinese people. The second class is Chinese related, which means it'll have terms where people are talking about China and Chinese related topics, but it's not xenophobic. And our third category is neither, so it'll include neither xenophobic terms, nor is it going to include Chinese related terms. These datasets came from different websites, and therefore they had different extensions. The most common was a variety of JSON objects, and we had to create this code here to iterate through each JSON object and categorize the big data set, which contained hundreds of millions of posts, into smaller data sets. We also had a .zst extension and a .csv extension, and therefore we had to change the code up a little bit to account for these new extension types. As the leader of the project, I was responsible for doing the majority of the coding, and this includes this section as well. So each of the JSON objects were only around 900 megabytes each, which means they could be imported into Python one at a time and iterate through each row, and therefore we could get the body of the text out. But for other extensions like .zst, they just come in one huge file type. So we had to incorporate a chunk reader where we would read it in 16 megabyte chunks, so therefore Python would be able to handle this. As mentioned earlier, we are using multi-class classification, and after the categorization is done, we would output the result into a CSV file, and here you can see we have different files for January, March, different months of the pandemic that we used. For this project, we only considered months that are between January and April of 2020 because these are the months that were the most discriminatory because the pandemic was at peak. At this point, we have a couple of subsets. We have subsets for xenophobic terms, we have subsets for Chinese terms, and we have subsets for neither. Now looking at an example here, we have the Reddit January xenophobic terms, and you can see that some of these are clearly xenophobic, whereas other of these are not xenophobic at all, and they're appearing xenophobic because of a key term, but we still have to have people go through this manually. This is where my teammates came in and played a big role. Now I would give them a subset of this data with, let's say, 1,000 or so posts each, and they're responsible for manually going through each row and deleting the ones that are not xenophobic while keeping the ones that are. Eventually, this data would be compiled into one large CSV file with terms that have been manually annotated, and from there on out we could proceed toward the machine learning. After that was finished, for each dataset we threw 1,000 xenophobic terms, 1,000 Chinese related terms, and 1,000 non-related terms into one CSV file. We gave the xenophobic terms a label of 0, we gave the Chinese related terms a label of 1, and we gave the neither related terms a label of 2. Even though they are in order here, when the machine learning model takes them in for training and testing, they are randomized, so there's no worry about this. Even though we have the classes prepared for the machine learning models, there's still a lot to do. So we have this pre-processing stage where we go through each of the rows and we basically clean them to avoid word repetition. For example, like words that can't and cannot mean the same thing, but they would be registered as different words under the machine learning model. So we have a bunch of different methods here to clean the data. Now other projects typically use a bunch of methods from the NLTK library and things like that to sort out their data and clean it. However, a lot of our methods here are created on our own due to knowledge of our domain. For example, there exists a library where you can import stop words and use their set of stop words to remove them, since these words typically have no meaning. But we created our own list with the words that I used in a previous project because these are more catered towards social media. In addition, we also have methods like removing URLs and removing hashtags and the user tag symbol because once again they provide no meaning to the machine learning model. We also lower each of the words and we remove extra symbols that are not necessary in addition to lemmatizing and stemming the words. So overall, our pre-processing stage is very customized toward our application, and this is where our data sets and our pre-processing strives over other projects. Even though our current setup is very good, there are still some flaws. For example, some of our rows that we're taking in after everything is cleaned up, they are only resulting in, let's say, a row with 2 to 3 words, which may be ambiguous for the machine learning model. So after we have time to gather more data and manually annotate it, maybe we can clear this problem and only consider pre-processed rows that are 5 words or greater or something along those lines, so our machine learning models have a better sense of what they should be doing. Now that we have the data organized into classes for each social media site, we can begin the machine learning process. The two models we decided to use were BERT, which stands for the bidirectional encoder representations from transformers, as well as a standard CNN or a convolutional neural network created from the word2vec word embeddings. BERT is actually created by Google, and it is a state-of-the-art machine learning model that specializes in natural language processing. Standard text classification models will only read words from left to right, whereas BERT will read them from both left to right and right to left. In addition, it has a second vector, which is a context vector. Now the context vector is especially important in our case because you can't always consider a word or a phrase to be xenophobic unless you look at the words surrounding them. For example, chink can be used in the phrase chink in the armor, but at the same time, if you use it in a different way, it can also be an example of xenophobia. On their repository, they have a series of BERT models. These models can be large models, base models, and even mini models, which can be found elsewhere. They also have uncased and cased, which differentiates between if casing matters in text, and they also have models that work with multilingual data. Each of these models only differs in the number of layers, hidden, heads, and parameters. Layers can be seen as a transformer layer, hidden is basically the output of the layer, and heads and parameters are standard. The models that we used were BERT base and BERT large, both of them being uncased because we are using lower cased everything. When trying to experiment with the BERT large model, we ran into a bunch of roadblocks. For example, we didn't have the computational power to run this. It required hardware that we did not have. And when trying to run this, we would either run out of memory, we would crash Python midway through, and it just was not working. So we stuck to the BERT-based uncased model, and you can see the results in a minute. When looking at the actual implementation of the model, we really didn't change a whole lot from the original project. We kept a lot of the layers the same. The only things we really changed were some of these numbers and hyperparameters just to tweak it and see if it would affect the accuracy at all, but the actual models, or the actual layers of the model, were not really tweaked. Coming down here to the creation of the model, we ended up using a variety of test sizes. We experimented with 10%, 15%, 20%, and even 25%, whereas the original project stuck with 10% for everything. And we also tweaked some of the hyperparameters here, such as the number of epochs, batch size, validation split, to see what would happen. When creating the actual data, both for BERT and CNN, it just takes the pre-trained vectors, or in CNN's case, the pre-trained word embeddings, to train the model, whereas the testing of the model is done on our data. For the validation and testing of both of these models, we opted for a 10-fold cross-validation test, just to ensure that the data was not experiencing underfitting or overfitting. We use 10-fold because many other researchers use this, and it basically encompasses the entire set of data, so we can see if there's any problems. Once again, we didn't create too much on this end. We did add a few things and we just tweaked some of the hyperparameters such as the test size, max sequence length, validation split, epochs, and so on to get the best possible accuracy. After running some experiments, we compiled some of the results into a couple of Google documents, and we found that on average, Parler was around 2 to 3% more accurate than Reddit for BERT. And this is including a tenfold cross-validation score to ensure that the models are not underfitting or overfitting. We believe this is the case because Parler has a lot more variety of data as it's an alternative site, whereas Reddit is more mainstream and you don't see as much variety. In fact, a lot of the xenophobic terms and posts are very sexualized, and a lot of them are kind of the same, which makes me think that bot accounts are actually creating these posts and putting them on. So it's more difficult for the machine learning models to differentiate between what is actually xenophobic and not, because um, the sample of xenophobic data is very similar. Moving on to the CNN, we didn't really change too much here again. We stuck to the original layers that the previous owner used, which includes the embedding layer, the convolution layer, the max pooling layer, as well as the softmax layer, which also makes an appearance in the BERT model. We did change some of the parameters, such as the dropout rate, just to see if putting a slightly higher rate or slightly lower rate would change the accuracy, but that is basically it. Our CNN is built off of primarily word embeddings, and these word embeddings are created through word2vec, which translates words into a vector that can be used by the machine learning models. The four corpuses that we decided to work with were Google News, 2017 Wiki corpus, a conference corpus, as well as the GigaWord corpus, which is encapsulated from a lot of different news sources. Each of the four corpuses are created from a 300-dimension word vector. However, the conference corpus is actually created from a 100-dimension word vector, and we will look at the results right now. Once again, a lot of the results were compiled into a Google document, and the most accurate corpus for Parler was GigaWord, followed by Google News. This makes sense because Parler is highly political, and of course you're going to hear about politics on the news. And even though Wikipedia and the conference corpus had high accuracies, it makes sense why they're not as high. When looking at the Reddit data, the highest scoring corpus was actually the conference corpus, with an accuracy of around 95.5% at its peak, whereas the lowest one was the GigaWord corpus. Once again, this makes sense because Reddit is not as political as Parler, and there's a lot more common everyday language used, which makes sense why the news corpuses did not perform as high in this case. Looking at these results in more depth, you can see that we also calculated the F1 score. The F1 score for the Reddit posts are significantly lower overall compared to Parler, and this is because there are more false positives and false negatives created, because the Reddit data is certainly more ambiguous than the Parler data. To sum everything up, both CNN and BERT were rather accurate for both social media sites. However, it seems that Parler outdid Reddit by a couple of percent in both cases at the best case scenario and worst case scenario. Although the corpuses used in CNN and the BERT models that we used did create an alter in accuracy, it seems like the main reason that the accuracy is different is because of the social media site. Therefore, we should focus on perfecting the data sets in the future so we can just understand how accurate these machine learning models actually are. And once again, to sum everything up, I was responsible for the majority of coding and testing these models because I had the best hardware out of everyone here, and I also had the most experience in machine learning due to my previous projects, even though it wasn't very much. Whereas the other three team members were more responsible for manually annotating the data to ensure that these models were as accurate as possible. In the future, we plan on expanding to additional data sets as well as additional models. I believe that a good start would be to focus on more data sets because even though Reddit and Parler are a good beginning, exploring and expanding to new options such as Twitter and YouTube would give us probably a more accurate representation of what everyone is saying, because not a lot of people are familiar with Reddit and Parler. In addition to that, we should focus on expanding the current datasets we have, because currently we're only using 1,000 posts per class, and I believe that using something like 2,000 or 3,000 at least would be much better, and it'll give us a more accurate representation of these models. After we expand on this and fix the known errors, I believe that it would be a good idea to work toward making these datasets publicly available because they are very customized to each social media site, and they could possibly help other people with machine learning in the future. Now that basically wraps everything up, so thank you.